All right, our final inverse trig example from our lecture notes was this lovely question that asked us to find the second derivative of arctan of x squared. So we know we're in inverse trig land because we have our little tan with a -1. There's our arctan. And then we also make a note here, just like in our previous question, our argument in that inverse trig function is not just x, it's x squared. So we're in chain rule land. And then, of course, yeah, we see we want a second derivative, so we've got some work. Let's get there. So we need g prime of x. Now, just like we did before, the derivative of arctan is 1 over 1 plus stuff squared. So we'll leave that inside function alone. I think this is the part students struggle with the most, just like with ln at the beginning when we just want to write down that the ln, like the derivative of ln of something is 1 over x, like we want to put that in there. We are doing 1 over stuff, or in this case, 1 over 1 plus stuff squared. And then, of course, if we want to move a little slower, we could write down we still need to take the derivative of that inside function, but we're past that. We're past those times in our lives. So we're just going to go ahead and do that. This is 2x. And we might want to clean this one up just because if you have to take a second derivative, that is really, that and what we're going to be doing next time with finding when these things are equal to 0, making plus minus tables, all the work we're about to head into, it means that we shouldn't just leave things in their like first format. So if we're going to do this, let's go ahead. Let's rewrite it. This is equal to 2x. And now that thing I was doing last time is going to be helpful. 1 plus x to the fourth. Now this is useful because if we just left that x squared squared, we're going to have to do a chain rule instead of a quotient rule. And that is not my favorite thing in the world to do, especially when we don't need to do it. But now that I have cleaned this up a little bit, I am now in quotient rule land. Exactly. Like as this is, it's like we have a quotient with a chain, but then because it's also written really sillily, that's a weird word to say, we technically do have a product as well. So like the way this was originally written is just absolutely hellish in terms of continuing on with another derivative. So instead, like the tiniest bit of algebra, we are now just in quotient land. Life is good. Life is happy, right? I mean, life is never really happy in quotient land, but it's better than it was. So let's go ahead and take our second derivative of this cleaned up version of our function, our g prime of x. So g double prime of x, our second derivative, that's a low d high minus high d low all over low low. You guys are pros at the quotient rule by this point. Now, here we're lucky. We don't seem to have any other reason that we should clean this up. They've asked us for the second derivative. They didn't ask us for any additional stuff. So not a bad place to stop, but you know I'm extra, so I'm going to keep going, especially because what if, you know, magical things happened and this is actually really pretty. So I'm going to go ahead and distribute that 2. Actually do some multiplication here. Okay, it gets a little bit cuter. We're looking at 2, that's minus 6 x to the fourth all over 1 plus x to the fourth squared. I mean, if we want to be real, real fancy, we could factor a 2 out of that. It's not really buying us anything, but you know, sometimes I get students who like to show off, so that's a way to show off. So yeah, these are all equivalent answers. They will all work. I will accept all of them. But if I tell you need to simplify or factor, right, your simplest version is here and your factored version is here. I think these are both beautiful. If I asked you simplified and you went factored, I wouldn't be mad. If I asked you factored and you stopped at this step here without factoring out the 2, maybe minus a point, you know. But that was our final example. Another one where we're seeing that, like, okay, don't forget If there's something other than just an x in an argument, you need to go ahead and sort of use those u versions, right? The derivative of arctan of stuff is 1 over 1 plus stuff squared times the derivative of stuff. That sort of same rule again and again, and practice it.